Hi everyone, and welcome to this video going over lesson 5.2, midpoint on the coordinate plane. In the last video, we talked about how we can find the distance between two coordinate points. And in this video, we are going to talk about the midpoint formula that can help us find the coordinates of the midpoint for a segment graphed on the coordinate plane. So let's get started. In this picture, I have 4 different segments plotted on the coordinate plane. And what I'd like to do first is jot down all of those coordinate points for the endpoints. So starting with segment AB, I see that point A is at the point 2, 2. Remember to write a coordinate point, it goes X and then Y. Point B is at the point 2, 6. Now moving on to segment CD, point C is at the point 5, 7. And point D is at the point 11, 7. Moving on to segment EF, point E is at the coordinate point 4, 1. And coordinate point F is at the point 6, 5. And lastly, GH, point G is at the point 8, 4. And point H are at the coordinates 14, 0. Now that I've jotted down the coordinates of the endpoints of each segment, I want to write down what the coordinate points are for each midpoint. So you can use a ruler or you can approximate. For example, AB, if I had to plot a point directly in the middle, since it's straight vertical, I can just count how long the segment is. The segment is 1, 2, 3, 4 units long. So half of 4 is 2, which means this blue point is the midpoint, and the coordinates are 2, 4. Next for CD, since CD is perfectly horizontal, I can also just count how long the segment is. 1, 2, 3, 4, 5, 6 units. Half of 6 is 3. Which means if I count 3 units in, right here is the midpoint at the coordinates 8, 7. Now for EF and GH, since they're diagonal, I can't just count how long they are and cut it in half. I have to approximate. So if I were going to approximate, I would say that the midpoint is about right here for EF, and that's the coordinate point 5, 3. And if I was going to approximate where the midpoint is for GH, I would say it's right about here at 11, 2. So what I'd like you to do is look at this table and see if there are any patterns between what the coordinates were for the endpoints of the segment and what the coordinates of the midpoint ended up being. Remember, midpoint is the middle of the segment, so it would make sense if the midpoint came from the middle of both the x-coordinates and the y-coordinates of each endpoint. For example, for AB, if we added the x-coordinates together, 2 plus 2 is 4, and 4 divided by 2 is 2. If we added the y's together, 2 plus 6 is 8, and 8 divided by 2 is 4. In CD, if we were to add the x values, 5 and 11, that is 16, and 16 divided by 2 is 8. If we were to add the y values together, 7 plus 7 is 14, divided by 2 is 7. So what you should see is that the x-coordinate and the y-coordinate of the midpoint are the averages of the x and y coordinates of their endpoints. So in order to find the coordinates of the midpoint, we are going to take the average of the x and y coordinates of the endpoints. In order to take the average, we add the two values together and divide by 2. So let's write the midpoint formula. If we had the following endpoints, x1, y1, and x2, y2, we are going to add the x values together and divide by 2 to find the average of the x's, and we're going to add the y values together and divide by 2 to find the average of the y values. Whatever the average of the x coordinate is ends up being the x coordinate for the midpoint, and whatever the average of the y endpoints are ends up being the y coordinate for the midpoint. So let's try this. In number 4, it says use the midpoint formula to find the coordinates of the midpoint M of line segment AC with the following endpoints. So just like what we did with the distance formula, where we labeled x1, y1, x2, y2, I'm going to do that again. Remember, each coordinate point has an x and a y. So x1 and y1 stick together, and x2 and y2 stick together. And I'm going to plug in these values into my midpoint formula. So I have to add x1 plus x2. x1 is 1 plus x2 is 11, and divide by 2. Then I'm going to add y1 and y2 together. y1 is 4 and y2 is 10, and divide by 2. 1 plus 11 is 12, and 4 plus 10 is 14. And then lastly, 12 divided by 2 is 6, and 14 divided by 2 is 7. And so the coordinate point 6, 7 is the midpoint of this segment. And we found that by averaging the x coordinates of the endpoints and averaging the y coordinates of the endpoints. Let's try this a few more times. So in A, I have the endpoints -3, -4, and 5, 8. I'm going to start by labeling x1, y1, and x2, y2. And I'm going to copy down my midpoint formula so I know where I'm plugging in my values. x1 is -3 plus x2 is 5. y1 is -4 and y2 is 8. And now we simplify. -3 plus 5 is 2, and -4 plus 8 is 4. 2 divided by 2 is 1, and 4 divided by 2 is 2. And so the point 1, 2 is the midpoint of this segment. Let's try one more. Once again, I'm going to start by adding x1 and y1 and x2 and y2 so that I know where everything goes in my formula. x1 is 3 plus x2 is 7 divided by 2. y1 is 16 plus y2 is -6 divided by 2. 3 plus 7 is 10. And 16 plus -6 is also 10. And 10 divided by 2 is 5, which means my midpoint is going to be at the coordinates 5, 5. And so that is how we find the midpoint of two coordinate points. The midpoint is directly in the middle of the segment, so it makes sense that in order to find the midpoint, we take the average of our x-coordinates and our y-coordinates of the endpoints of our segment. Please let me know if you have any questions, and I will see you in class.